Saxon Algebra 1, Lesson 118, Completing the Square. This is a super important lesson. Like I said at the beginning of 117, John is introducing this to you now because next year we're going to come back to it and we're going to use it a lot, and then the following year as well. So what we're doing now is just kind of planting the seeds in your brain to give you an idea of how this works. It's okay if it's confusing to you because it's a super complicated way to sell it, right? But it's super useful and it's super interesting, and to me this is a lesson where students start to understand the thinking of mathematicians through history. Okay, that's quite a build-up. Let me get to it. We have been taking things like this and we have been factoring them, right? We look at this and we figure out a way to break this trinomial down into two binomials that you could then multiply together to go back, right? You can go back and forth between them. And we do that just by looking at it. We set it up like this, and we say, okay, what two numbers multiply to -5 and add to +4? Okay, I know it's gonna be x and x, that's at the beginning. And I can see, okay, it's gonna be +5 and -1, right? Because those multiply to -5, but they add to +4. So we have factored that, and we can even do this if we want, right? We can set it up as an equation, and then we solve it, right? We say, okay, if two things are multiplying together and they equal 0, then either x plus 5 equals 0 or x minus 1 equals 0. Either one of these statements being true would make this true, right? Because it doesn't have to both be zeros, just one or the other of these has to be a 0. And then we get x equals -5. That's just with a little, we whack it with our algebra stick, and this answer falls out. I don't know why. I always think of it as hitting it with an algebra stick. That's weird. So then we say that those are the two values of x that are our answer. Okay, we solved or factored this trinomial rather, sorry. We did it by inspection. John doesn't always use this terminology, but I do, because what we did is we looked at it. Right, there it is over there. We just looked at it and saw the answer by playing with numbers and finding it. We didn't do anything to calculate that. Well, we did in our heads, but mostly we just looked at it and thought about it and we figured it out. That works out great when our answers are integers. Okay, they're nice whole numbers, right? Negative or positive, it doesn't matter. But they're not fractions or decimals or, oh, God forbid, radicals or anything like that, right? Roots. So this method of inspection is a great way to factor or solve a trinomial. Okay? This first one, so now I'm making a list. The first way we've learned how to factor or solve a trinomial. Factoring is breaking it down. Solving is when you set it equal to 0 and go all the way to the answer. By inspection, but this only works for integers, because it's really hard for us to see decimals and fractions in our head. So we need some other strategies, and there are three main ones. We need some other strategies for doing that. The next one we're going to use is completing the square. Okay, that'll work for anything. Okay, that works for any kind of answer, which is cool because when we're just starting out a problem and looking at the trinomial itself, sometimes we don't know whether we can solve it by inspection or whether we're going to have to complete the square. Even when the numbers are easy, sometimes we just can't do it by looking at it. Here's the cool thing about completing the square. It always works. So you can't go wrong. And then I'm just going to give you guys a little, I think it comes up. Yeah. In lesson 119, we're going to learn quadratic formula. And you may have been introduced to this last year. I don't know. Probably not. It usually is Algebra 2 topic, but this is a formula we're going to use that relates to completing the square. So these two methods both always work. Inspection only works when the numbers are integers, all right? So this is, we're solving this same type of problem. We're being given a trinomial and we're being asked to solve it for x. We'll have two answers. Whenever we have a square in our original problem, that's a really good sign that we're gonna have two answers. But this method that we're gonna use is gonna accomplish the same thing for any kind of problem, any kind of answer. Okay, enough talking. There's a lot of steps to this. But don't worry, I've got you. I will get you through it. There are 3 problems, so buckle in for a long ride. I teach it somewhat differently than John, so you might want to take some notes. Pause me and make sure you have paper so that we can go. Okay, here's our problem. Solve, it says solve this thing by completing the square. X squared plus 6 equals. Okay, that's what we're given to start with. Now, you can see by looking at this, annoying, it's got an equal sign, but this is not arranged properly. So, in our steps, the very first step is arrange in what we call standard form. And what that means is you get the x squared term, and then the plain x term, and then the plain number term on the left side of the equation in this order. You set the other side equal to 0. So, I'm going to add 10x to both sides. Whoops, I can't write the number 10. That's sad. And now we have x squared plus 10x plus 6 equals 0. Okay? The second one, and I choose my words carefully because someday I'm going to come back to these words and explain to you why I said it the way I did. We're going to kick C to the curb. John definitely does not have that printed in his book. It might not be official mathematical speak, but you know what? This is what I mean. Here's our C term, right? C is the plain number. We're going to kick him to the curb, which means he goes to the other side of the equal sign. So now we have x squared plus 10x equals minus 6. Notice I left a gap there, okay? I did that on purpose. I could have closed this up the way I wrote it, but I purposely left a gap there because what we're going to do is we're going to put a magic number in the gap. Step 3. Calculate the magic number. Sometimes Christian families get upset when I use the word magic. I don't mean like the occult. I mean a number that's going to solve our purposes in a very specific way. So it's gonna work like, you know what I mean. I'm not talking about wizardry or Wiccans or anything creepy. I'm just talking about math, man, and math is never creepy. Okay, here's the way we take our this is the way we calculate our magic number. I refer to it as the MN, so I don't have to write magic number every time. It equals the number in the B position divided by 2 quantities squared. And we always draw an arrow to what's inside the parentheses because that has a very important value to us, all right? So, we calculate our magic number. Oh, look, I forgot to put the x there. I bet that's been driving somebody crazy all this time. So we take the b value, 10, we divide it by 2, and we square it. That number is 5. 5 squared is 25. So we add 25 to both sides, okay? I better make that. Add to both sides. All right? That is technically the part where we have completed the square. Okay, the fourth step is create a perfect square on the left. Okay, what the magic number does is it sets this up so that we will have the same binomial times itself, okay? The number that is inside the magic number calculation that I pointed the arrow to, that is the number that will go in our binomial. So I know this is going to be x plus 10 divided by 2 is 5. It's going to be the same in both binomials. That's what I mean by a perfect square. Okay, now we test it to make sure that it works. 5 times 5 is 25. 5 plus 5 is 10. Okay, it works. Beautiful. Now on the right side, we can simplify that. It's 19, right? Create a perfect square on the left, and then the other part of this one is simplify the right. Okay, I should have made my steps column wider, but it's too late for that. So now I'm going to take this to the next page, and I'm going to be on step 5. I'm telling myself, not really you. Okay, steps 5, and it was x plus 5, x plus 5 equals 19. Okay, this step is it's one that you'll be able to skip over, and we'll talk about that as you get further into this. Probably mostly next year is when we'll talk about this, but you can streamline these steps a little bit. I'm giving you now the most careful, deliberate, step-by-step instruction. Later we'll put it into hyperdrive. Okay, so now we're going to rewrite as a square. Okay, so I don't have to write this separately. I can write x plus 5 quantity squared, right? This is just a neater way to write that. Okay, 6. Take the square root of both sides. The reason we do that is because we want to simplify this, right? We're squaring it, so if we take the square root, then we have canceled that out. So now I get x plus 5 equals, notice we have to go plus or minus, right? Because when you take the square root of a number, the roots could be both negative or they could be both positive. All right, we're almost done. We still have to get our little x by himself. So the way that we do that is subtract, whoops. I want to put a star by this and remind you to use the plus or minus. Okay, and then subtract to solve. And so minus 5, and so this is the way we write the answer. X equals minus 5 plus or minus the square root of 19. So going back to our original problem, which didn't look that bad to begin with, just a second, I'm looking at the back of my page. It was x squared plus 10x plus 6. Okay, this is the value of x for this equation. We could not have looked at that and solved it by inspection, could we? Who would have ever guessed this is the monstrosity that would come from that? But we can do it because we know how to complete the square. Now, 7 steps, what the heck, and that whole magic number thing, it's so much to remember, you guys. Right now, if you're just like, yeah, I got hit by a truck, I have no idea what we did. That's fine, don't worry. We're gonna do it again 2 more times, and then you'll be able to use your notes to follow through. Like I said, John doesn't teach it exactly the same as me, so use this video as a resource to go back and get the steps if you did not write them down. Don't even tell me if you didn't write them down. It'll just make me sad. But you can always go back and look. Although I can always go back and look at my viewing counts on YouTube, and I'll find out if you guys had to watch it 85 times to figure it out. But that's okay. I'm fine. I love that you have this as a resource to watch. Okay, we're gonna do the whole thing again. Are you ready? I'm not gonna write down the steps this time, but I'll remind you carefully. Okay, complete the square to solve. X squared plus 3 equals minus 5x. John, really? Really? You have to do this to us? All right, so the first thing we do is we put it in standard order. That's gonna be x squared. I'm gonna swim this over. That's gonna change the sign. That's better, right? Now we're gonna kick this c term to the curb, which means moving it over so it becomes minus when I move it, and I leave the gap right there. Now I calculate my magic number, because that's what goes in the gap. 5 divided by 2, quantity squared. I draw an arrow to what's in there, because that's going to be useful. 5 divided by 2, 5 over 2 squared makes a fraction. That won't simplify. Don't worry, it's okay. Just do this. It's 25 over 4, right? I have to add it to both sides, right? This equals 25 over 4. Let me write that down so you know where I got it, right? 5 squared is 25, 2 squared is 4. I add it to both sides. I leave myself some room here because I know in order to add these, I'm gonna have to give this a denominator of 4. So here's a little bit of room for me to work without going mad. So I'll get to that later. But right now I wanna pay attention to this side, and I want to write it as a pair of binomials. And I know that what's inside of here is what I put inside the parentheses. Okay? I know that's the process, but I also always test it to make sure. So 5 over 2 times 5 over 2. It's just like the by inspection thing, right? They have to multiply to this and add to that. Multiplying, it's 25 over 4, yep. Adding, it would become, the denominators match, so it would become 10 over 2, and 10 over 2 is 5, so that works. Okay, beautiful. Let's do this, let's fix this side at the same time so I don't have to keep writing something gross. Minus 3 needs to have a denominator of 4, so I'm gonna multiply it by 4 over 4. And that becomes minus 12 over 4. Now I can add them. The 4's match, so they're done. And this becomes positive 13 over 4. Okay, a little bit of fraction work in this. That's the only thing that makes these fraction, if your magic number turns out to be a fraction, this is really the only drama, is just we have to fix this so we can add them. Okay, now we can rewrite this as a square. And this reminds us, this is how my brain triggers each step, right? We put this in order, we kick that to the curb, it creates a gap that reminds us what goes in the gap. Oh yeah, the magic number. We put the magic number in and we eventually get it down to this point. We see this square here and we go, oh yeah, we have to get rid of that. This is how we do it, right? Those two are opposites of each other. This now is fine and all by himself, but we have to take the square root over here. We remember it's plus or minus. Now square, I can mentally go like this, right? They're in separate houses. This is not gonna go anywhere. Square root of 13 is yucky, but square root of 4 is, 2. It will always work out that way, you guys. The denominator will always pop out and become a wolf, so to speak, a regular number. It's not a pig anymore. We can set the denominator free, but the numerator often stays stuck. So it's plus or minus square root of 13 over 2. All right, we're almost there. All we have to do now is subtract 5 over 2 from both sides, because that's how we get our x by himself, and we get x equals, ready? Minus 5 over 2 plus or minus square root of 13 over 2. Wow, that's our answer. Isn't that disgusting? But it always makes me feel better because it's like, okay, no wonder I couldn't solve it by inspection. Even though it looked harmless, didn't it? Look, that looks easy. 3 and 5, those are baby numbers. But it just turns into this hideous, long, complicated answer. But that's okay. That's why we know how to complete the square. Okay, and we leave it in this form. We're going to talk more later about why this form is preferable, even though the denominators match and we could technically squish that into one big fraction. I prefer, and most mathematicians prefer, to see it separately. And like I said, we'll talk about why that is later, but for now, just leave them separate. Okay, one more, and then we're done. And you will have done, I mean, this is, you guys, really one of the most involved lessons ever. Complete the square to solve x squared plus 1 equals 3x. Looks harmless, doesn't it? A 1 and a 3. Okay. Standard form, x squared minus 3x plus 1 equals 0. Kick to the curb. X squared minus 3x equals minus 1. Fill in the gap with the magic number. Minus 3 divided by 2, quantity squared, number there, or arrow there. This equals 9 over 4, right? It becomes positive. Add to both sides. Give it some room to do the adjustment calculation. Write it as a square. So it would be x minus 3 over 2. We use the arrow to guide us to the answer. Now we test it. Minus 3 halves times minus 3 halves is positive 9 over 4. And then together they become, when we add them, it's minus 6 over 2. Minus 6 over 2 simplifies to minus 3. Okay, so that works. Over here, we're going to clean this up. I need a 4 on the bottom, so I'm going to multiply this by 4 over 4. We get minus 4 over 4. And then we add those two together, and we get 5 over 4. Okay, we can write this as a square instead of having it separate. X minus 3 over 2 equals 5 over 4. Whoops, I forgot that. Now to counteract this, we do that. We get x minus 3 over 2 equals, now here we go, plus or minus, and then remember, this is what my brain is doing in my head. And then final step, we isolate the x, right? That's what we're trying to do, is get that x by itself. And we get x equals 3 halves plus or minus the square root of 5 over 2. Again, leaving those as separate fractions, even though the denominators match. This is the presentation we like. If you're exhausted, if you're a little bit dizzy, if you feel like you really need to go outside and jump on the trampoline for a few minutes, good. That means I did my job, and you're well on your way to learning how to complete the square. Congratulations. See you next time.